Right, so let us have a discussion on this collision. Actually, this collision is a part of work, energy and power only. Okay, so this is a part of the chapter work, energy and power. So actually, what is collision? The very first thing what we need to know is collision. So what we can say that what is the collision? You can say that if any two body or more than two body are striking or hitting against each other, that can be said as collision. Right? Very good. So when two bodies they are moving, so either both of them are moving or one is stationary and one is moving. Right? So two conditions are there, and when they are coming and hitting each other, that hitting is also in two ways. Either they are hitting each other head on, means head on collision. Both are moving in opposite direction and head on collision is there. Right, this is one point. Another point is if one is moving ahead, another one is moving at the back and hitting each other. Okay, these two conditions are there. That is called collision. So in each and every time, collision of two bodies means one body is in motion, another body also may be in motion or may be stationary, but one body compulsorily has to be in motion. Right? Okay. So what part actually we are going to discuss in this collision? Actually energy. We are going to discuss about that how distribution of energy is taking place. We have already discussed one point, and that is called conservation of energy. Conservation of energy. In that conservation of energy means what? Whatever amount of energy initially if a body is having, that amount of energy always it will be having. Right? So energy is not lost. It may be converted to from one form to another. Energy can be converted from one form to another. What conservation of energy actually says? It says that energy can neither be created nor be destroyed. So it says that additional amount of energy cannot be created nor be destroyed. Energy cannot be destroyed. Okay, it can only be converted from one form to another. Correct? So now what it is there, suppose the fan which is working overhead, so that fan consumes electrical energy. When electric supply is being given to that fan, it starts working. So it starts working means what? That motor, okay, in that shaft is there, it has started rotating. Once it has started rotating, the blades are flowing air to us. Okay, that rotational motion of the shaft which is taking place inside that electrical device, that is mechanical motion. Correct? So in the fan, if you will take the example of a fan, so in a fan, what happens? Electrical energy is converted to mechanical. Yes, is converted to mechanical energy. Mechanical energy. Right? Okay. In our home, morning itself we switch on the motor for water supply. Okay, so that motor we are supplying electrical energy. Then that mechanical energy is used to draw water from underground. Correct or not? From underground water is drawn and then again it is sent to the tank. It is sent to the tank. So that water, what it is there, it was in underground position. Okay, now its level is increased and kept at the rooftop in that tank. So its potential energy is increased. Correct? So energy can neither be created nor be destroyed, and it can only be converted from one form to another. Okay, so this particular concept we are going to use here. Another concept what we are going to use, that is conservation of momentum. Conservation of momentum. Okay, so this conservation of momentum we know. Momentum is
change.
So momentum is product of mass and velocity. Very good. So you can say that momentum which is denoted by P is equal to mp, right? Further, which can be written as the force applied with respect to a small interval of time. So F delta T can also be written for change in momentum. Right. So momentum is product of mass and velocity, and momentum is also conserved. Momentum is also conserved. Conservation of momentum is also applicable in the system. That's why we are going to use these two particular concepts in collision. First we are discussing these two particular concepts, so that once it will be clear, here we will not face any problem. So conservation of momentum also says that initial momentum of a body will be equal to the final momentum of the body even after collision. So there will not be any loss of momentum. Understood? There will not be any loss of momentum. Initial momentum will be equal to final momentum. So it clearly says that initial momentum will be equal to final momentum. Right? So which is, you can say, Pi is equal to Pf. Okay? Good. So this particular concept we are going to utilize in collision. So collision, what we can say, that two bodies in which at least one body should be in motion. At least one body should be in motion. Okay, two bodies in which at least one body should be in motion hits or strikes against each other. Strikes against each other. Okay. So this process of happenings is called collision. Is called collision. Is called collision. Right? So suppose if a body is having mass some m1 and it is moving in this direction, in between any other body m2 is having, it may be static or it may be motion. Okay, for our calculation purpose we consider that this is stationary. Any one body we will assume that it is stationary and one body we will be assuming it is in motion. Okay, so in this case its velocity will be equal to 0. What you can say that its velocity will be equal to 0. It is having some initial velocity. Correct? It is having some initial velocity v1i. So we will be writing as v1i. Now when this body m1 is moving with velocity v1i, is going and hitting this particular body m2 which is at rest. Okay, so what will be the course of action? This particular body will also move due to that impact. This body also will be moving. This will also get deflected in some direction. Okay, there are possibilities that the velocity, this particular body will be moving in this direction with reference to this reference. Suppose this is x-axis and we are taking it as y-axis, right? So you can say that one body will be moving in this direction, correct? M1, and another body will move in this direction, M2. So it will also have some velocity. V2 F some velocity will be there, and V1 F some velocity will be there, and at some angle you say, suppose it is θ1 and it is at θ2. So this happening has occurred after collision, whereas previously this body was at rest. But when this body which was moving at some velocity has come and hit this particular body, so this particular body also will move. Now we see the condition where this particular body is a very heavy body and this particular body M1 is very small mass. In that case, what it will be there is a small mass only will be moving it back. This particular body nicely it will be sitting at one place. Suppose we are going and hitting one mountain. Okay, so mountain, nothing will happen to the mountain. Rather, we will only be thrown back. So that type of case is different. When comparatively you can say both of are same mass, then this type of action may take place. Either it may move in only one line or it may move in different directions. Correct? Okay. Understood now? Right. So types of collisions. Types of collisions. So you can say that suppose this two body is getting heated by each other, and then what happens, this body is moving in this direction, this body is moving in this direction. So this type of collision is called elastic. Elastic means body gets separated. Body will get separated with each other. Right? Okay, just like a spring, they may regain their shape, they may not regain their shape, but they are getting separated. That is called elastic collision. But suppose another case is there when this body is hitting this body, both the body will move each other, means both the body will be moving together. Okay, in that case what will be there? Both the body M1 and M2 will move together as a single body. As a single body. M1 and M2 both will get collided and will move as a single body. In that case it will be called as inelastic collision, or you can say completely inelastic collision. Completely inelastic collision, right? Or inelastic collision. So we do have two types of collision. One is called elastic collision and another one is inelastic collision. Inelastic collision. So in elastic collision, what happens after collision? The bodies moves separately, correct? Body moves separately, right? But in inelastic collision, after collision, the bodies moves as a single unit, as a single mass. M1 plus M2 will be there as a single mass. Understood? So this is called inelastic collision. Completely, if both of them are together, then it will be called as completely inelastic, or little bit if something is there, then it will be inelastic. But it is inelastic collision. Two types of collisions are there. One is elastic collision, another one is inelastic collision. Right. Now, why we have studied here, in this case, when we will be solving questions, then we will see, in elastic collision, these two, conservation of energy and conservation of momentum, both are applicable. Both are applicable. So suppose if I am naming it as 1 and 2. So in this case you can say 1 and 2 both are applicable. Right? 1 and 2 both are applicable. But in second one, what happens? This 1 will not be applicable, only 2 will be applicable. Conservation of momentum only is applicable, conservation of energy is not applicable. Okay, so in this case, only 2 is applicable. M2 is applicable. Correct? Okay, so just please note it down. Then we will find the expression. Right, so we will continue with our discussion. And now we will be deriving some of the expressions. So both of this we have already understood, conservation of energy and conservation of momentum. So how these will be applicable for us, that particular part we will see. Right? Okay. So can I have it? Here? Right. See, as I told that suppose one object is there, that is M1, which is moving with some initial velocity V1I, because it is V1 first body, so V1I we are writing, correct? Okay, and this is going and hitting another body which is M2, and its, you can say, initial velocity V2I is equal to 0. Now there are cases where you can say that if we are drawing anything in two-dimensional axis, x-axis and y-axis, so it will move in this direction. So suppose M1 and V1F here, another body will move in this direction, so V2F, and this is M2. Suppose this is theta 2 and this is theta 1 at angle theta 1 and theta 2. Right. So now let us study first in one dimension. It is in two dimensions. Let us study in one dimension. Okay, we will take, so collision in one dimension. One dimension means what? It is moving in a straight line. One dimension means what? Only one axis moving in a straight line. Okay, so in that case, suppose theta 1 and theta 2 will be 0. In this case, means theta 1 and theta 2 will be 0. Okay, right. So in that also we are having two cases. One is inelastic collision. Okay, suppose completely inelastic collision. Completely inelastic collision means what it is there? The body M1 moving, going and hitting another body M2, and after collision both of them have started moving together, M1, M2, means you can say both have started as one single body like M1 plus M2. Completely inelastic means they will be going and hitting each other, and after that they will move together like one unit, like one body. Understood? Okay, in that separation is not taking place. Separation is taking place in which type of collision? Elastic. Elastic collision. Right? Okay, so in that separation if it is taking place, that will be called as elastic collision. But if both of them will move together, like joined together, then it will be completely inelastic collision. Right? Okay. Now suppose it is moving in, you can say V1I, and this is V2 is also equal to 0. Take it as it is equal to 0. V2I is equal to 0. Stationary body, right? So this is stationary. Even if two bodies are moving, we consider one body as rest. We consider as one body as rest. Okay, right. Now in this case, the both of them together they are moving. So you can say that some final velocity Vf. Because here we cannot say that M1 is having different velocity, M2 is having different velocity. Both of them will be having one single velocity Vf. Yes or no? Okay. So in this case, as I told you that which is applicable for inelastic collision, conservation of momentum only is applicable, conservation of energy is not applicable. Right? Okay. So by conservation of momentum. So what it says? It says that initial momentum is equal to final momentum. Okay. So initial momentum of the body, you can say that m1 and v1I, right? Okay. Plus, what is the momentum of this body? M2 V2. Right. And V2I, what is the value? 0. Okay. So here it will become 0. No problem. Right. We'll see. Next step we'll write. So final momentum is this one. So you can say M1 plus M2 Vf. Yes or no? So from law of conservation of momentum, what we got? Initial momentum is equal to final momentum. Right. From here we got M1 V1I is plus M2 into 0 is equal to M1 plus M2 Vf. From here again, so this part has become 0. So M1 V1I is equal to M1 plus M2 Vf. And further, so M1, so we will write V1I. So what will be the V1I? Even if we are writing V1I or Vf, we can find out. Final velocity we can find out. So it will be M1 V1I by M1 plus M2. This will be giving you final velocity. Right. Now, conservation of energy is not applicable. Conservation of energy is not applicable. But loss in kinetic energy will be there. See, it is moving with some velocity. Suppose I am moving, wall is there. Okay, I am moving and going and hitting that wall. What will happen? My velocity will get reduced or not? That wall is not moving, okay, right. But my velocity will get reduced. If my velocity is getting reduced, it means what? It means that kinetic energy I have lost. Through motion I am having some kinetic energy. So I will be losing some kinetic energy. So loss in kinetic energy will be taking place here. So what it is? So loss in kinetic energy. So will be equal to initial kinetic energy. Okay. So initial kinetic energy I minus final kinetic energy. Right? Oh. In this case, kinetic energy loss. So now initial will be only this one is having kinetic energy. So you can say half M1 V1I square. For this kinetic energy is 0. For second body kinetic energy is 0 minus half. Then what is the mass? M1 plus M2 is there. M1 plus M2 and Vf square. Correct or not? Vf square. Now Vf already we have found this one. So we can utilize that value here. Okay, right. So now we will be placing that value of M1 V1I square minus half M1 plus M2. In place of Vf square, we will be putting a square here. So M1 square V1I square by whole square. For this Vf square is there, so we are putting over the square complete. So here square is there. So this 1 M1 plus M2 and it will get cancelled with 1 M1 plus M2. Yes or no? Right. Now what we are getting? We are getting that half M1 V1I square. Here also half M1 V1I square is there. Right. So it is half M1 V1I square. We are taking common. So here it will become 1 minus. So what it is? M1 V1 square. So 1 by M1 plus M2 we will get? No. Here M1 is there, na? Only M1 we have taken out. So M1 will be there. M1 will be there. See, half M1 V1I square. Half M1 square V1I square. So M1 V1I square. So one M1 is there, na? So M1 by M1 plus M2. So this one we can write half M1 V1I square. And here if we are solving, so M1 plus M2 minus M1 by M1 plus M2. Okay? Can I rub this side? Go. So from that, so loss in kinetic energy, which you can represent as delta Ke, is equal to half M1 V1I square, and then this M1 and M1 will get cancelled. So M2 by M1 plus M2. Okay, it will be giving you M2 by M1 plus M2, which you can write half M1 M2 by M1 plus M2 V1I square. Yes or no?
Yes.
So this is giving you loss in kinetic energy. This will be giving you loss in kinetic energy. Okay. Whereas this particular formula is giving you final velocity that body will be having. Final velocity. Okay. So here kinetic loss in kinetic energy we can find out in terms of VI. M1 plus M2 is given to us. V1I also will be given to us. We will be able to find final velocity after collision. Similarly, we will be able to find that how much loss in kinetic energy has taken place. Here also M1, M2 is given to us and V1I will be given to us. Most probably, most of the questions it will be given to us. We need to find after effect of the collision. So after effect of the collision, we will be finding from this particular M1 V1I by M1 plus M2. These two we need to find out. Yes or no? Okay. Now you see here that suppose case 1 we are going. Case 1. Case 1 means what? Now M1 and M2 both are depending on mass. Okay. Now what you can say that in case M1 is equal to M2, case 1 we are going M1 is equal to M2. Both masses are same. Now in that case loss in kinetic energy will be equal to what? Half into M square. Suppose M1 M2 is equal to M. Okay, and divided by M square, so 2M, M plus M, so 2M, and V1I square. So this M will get cancelled. Okay, yes or no?
Yes.
Right. So in this case we are getting delta E is equal to 1 by 4 M V1I square. Yes or no?
Yes.
Because 2M it has become 2M it has become 1 by 4 M1 VI square in case M1 is equal to M2. Right. Case 2. Okay. In case M1 is greater than M2. M1 is greater than M2. So if, okay, right, final velocity, what will be the effect in final velocity in case 1? What will be the effect of final velocity? So Vf is equal to what? M V1I by 2M. 2M. So this M has got cancelled and Vf will become what? Half of initial velocity. Half of initial velocity. Final velocity will become half. Okay? Due to this reduction in velocity, loss in kinetic energy is taking place. Yes or no? Right. Okay. So this was for case 1. Case 2, what it is? If M1 is greater than M2, means that moving body is having more mass than M2, then in that case loss in kinetic energy will be what? So M1 is greater. Okay, suppose it is much more greater. So you can say that M1 is having more predominantly, and here also M1. Correct? Okay, so M2 is smaller and M1 is more larger. So you can assume that this particular part will become M1 only. M1 only. Right? Here also M2 is very negligible, very small, and M1 only is more. So in that case, what it will be there? So you can say kinetic energy will be equal to what? Half M1 M2. By here M1 only you can write. Okay, M1 only we can write. So M1. Okay, and given I square. So it is giving you half M2 given I square, where M2 is very small. M2 is very small. Okay, small. So loss in kinetic energy will also be little small, but it is depending on initial velocity. Final velocity, what we can say? Final velocity M1 is larger. This also will become larger. Correct or not? Okay. So this is similar to M1 only. So Vf will be almost all equal to given I. Right? Okay. Almost all equal to given I. So you can say Vf will be almost equal to given I. Okay. Case 3rd. What case 3 is telling? Here I will write. In case 3, this M1 is small and M2 is big. Considerable mass is there. Like this wall is there. This wall is having more mass than me. Even if I am going and hitting, nothing will happen to that wall. Rather, it will affect me. I will be bounced back side. Okay. So in that case, what it will be there? You can have a glance. So M1 is smaller than M2. Correct? Or we can write M2 is greater than M1. In case 2, M1 we assumed as greater than M2. In case 3, M2 is greater than M1. So in that case, what will be there? Loss in kinetic energy will be equal to what? So M2 is greater. So M2 you can take here, and here also it will be M2. So you can say half M2 by M2 given I square. Correct? So it will be almost all given I square. Right? Okay. Or M1. So M1, M2, M2. Right? M1 and M1 also you are writing, then this will be getting cancelled. So half M1 given square. Correct? M1 given I square. Whereas Vf, final velocity. So M1 is smaller. Okay. M1 is smaller, and here what we are getting? M2. M2 only. Yes or no? So now in this case, M2 is more bigger than M1. M2 is bigger than M1. Okay. Right. So final velocity will be equal to what? Similarly, it will be more bigger if it is there. Then M1 can be negligible. Can be assumed as negligible. Okay. So this one will be giving you like 1 by M2 and given I. Yes or no? Given I by M2. This particular final velocity. So this is for case 3. Right? This one we can do it. Okay, just note it down, then we will go for elastic collision. So very important, not only for your board examination, for your competitive examinations also it is very important. Because this collision question, 100% question is coming in the examination from collision. Why? Because this is related with our day-to-day life. Yes or no? Many accidents are taking place on road. It is mostly due to collision only. So that's why it is very important and it is applicable in our day-to-day life. So those questions which are related to our day-to-day life are being asked more nowadays in examination. Right? Okay. Right. So another one we are going to discuss about now, elastic collision. Elastic collision. As we continued our discussion in one dimension, we did not discuss till now about two dimension. Okay, we discussed about in one dimension only. So elastic collision also will be discussing in one dimension. So what I told in elastic collision, the body will be moving separately. The body will be moving separately. Right. So in this case also a body M1 which is having one initial velocity is moving and going and hitting another body for which velocity some M2 velocity is there and its initial velocity you can say is equal to 0, stationary body. We assume it as stationary body. So this one is stationary and this is moving. But in this case the after effect of collision, that both the body will not move together. Both the bodies moved together only in inelastic collision. Now in this case the bodies will be moving in separately. Okay, separately. So suppose you can say M1 mass is moving with some initial final velocity V1F. So it may move in opposite direction or it may move in same direction. Correct or not? It may move. We cannot say that both of them are moving in opposite direction. No. It may move in opposite direction or it may move in same direction, but only in one dimension. And another velocity M2, another object M2 is moving with some final velocity. Yes or no? But both are moving separately. Now in this case, as I told, both conservation of energy and linear momentum conservation both will be applicable in this case. Okay? So by law of conservation of momentum, initial momentum will be equal to final momentum. Okay. So now in this case, initial momentum is this one only. Its momentum is 0 because its velocity is 0. So no need to write. Right. So its initial momentum, you can say that M1 and V1I is equal to, now final momentum. Okay, I will write here once as 0 plus M2 and V2I. Final momentum will be this one. So you can say M1 and V1F plus M2 and V2F. Yes or no? From this, what we are getting, M1 V1I plus it is 0 because V2I is equal to 0 is equal to M1 V1F plus M2 V2F. Okay, right. And further it is giving you M1 V1I is equal to M1 V1F plus M2 V2F. This is one equation we got. One equation we got from conservation of momentum. Right? Second, conservation of energy. So now, law of conservation of energy. So here loss in kinetic energy is not taking place. Here conversion of energy will be taking place, but kinetic energy, initial kinetic energy will be equal to final kinetic energy. Right? Okay. So in this, initial kinetic energy will be equal to final kinetic energy. Initial kinetic energy, you can say that half M1 V1I square plus half M2 V2I square. This will be the initial kinetic energy. Final kinetic energy half M1 V1F square plus half m2 b2f square. Correct? Okay. Now this portion, because b2i is equal to 0, this one will become 0. Okay? Can I come this side? Right, okay. So you can say that half m1 b1i square further plus 0 is equal to half m1 b1f square plus half m2 b2f square. Yes or no? Yes. Okay. So half, everywhere half is there, so we can cancel. Left side, right side, both half is there, we can cancel. So it will become m1 b1i square is equal to m1 b1f square plus m2 b2f square. This is another equation. Right? Two equations we have got. Right? m1 b1i is equal to m1 b1f plus m2 b2f. Yes or no? Yes. Okay. Now, what we need to do? Here we will solve for b1i. Okay. Right. Both are moving in separate direction. Right. m1 b1i. So both equations now will be writing at one place, and we will find out. So can we place this one m1 b1i square? Here square is there. Right. So what we will be doing? Let us go for multiplication of this one. We will make it as b1i square. Okay? So here suppose if you are making m1 b1i square, so you have to multiply it with b1i, both the sides. So suppose if we are multiplying, we can write m1 b1i square is equal to m1 b1f b1i plus m2 b2f b1i. Yes or no? Yes. Now m1 b1i square, can we put this one that side? Okay. So here suppose if you are putting, then you are getting what? m1 b1f b1i. Yes or no? Plus m2 b2f b1i is equal to m1 b1f whole square plus m2 b2f whole square. Tell me yes or no? Yes? Okay. Right. So now here what we have got m1 b1f, m1 b1f here. Similarly m2 b2f, so we will take that side, whatever it is relevant. So m1 b1f. So b1i minus this b1f. Okay. And another side, what we are taking?
m2 b2.
So m2 b2f. Correct? Now b2f, this one will go that side, minus b1i. Yes or no? Okay, right. So this we have got now. Here b1i minus b1f, b2f minus b1i. This particular expression we have got, and in this expression you can say what we will be getting. Suppose you bring this side, m1 b1f by m2 b2f is equal to what? b2f minus b1i by b1i minus b1f. Right? This particular expression we are getting from these two. Otherwise, this is the main equation. These two are the main equation. If we are further solving it, we are getting this one, m1, m2, b1, b2f. Okay, b1f, b2f, and this one, this expression we have got. Okay, just note it down, then further we will write.